Hello everyone, you're welcome to biology video lecture series. I am Akerele Oladimeji. How has been your week and all? Alright, on today's edition of the lectures we'll be talking about ecology. Right, and before we go into ecology proper, I have a diagram here that might help us in understanding some basic things and probably also remind us of some things that we might have forgotten. All right, and bear in mind that this video is a summary of the topic, so I might not go into details. That's why you have opportunity to contact me. Probably have something you want to explain all the way, all right, or deeper. Now, this is a pyramid that explains different things at different level, or things that aggregate to form a particular level. You can see here at the atom, molecule, organelles form cells, and I believe most of us are familiar with cell to organisms. So I want us to relate everything together. This is really good in the sense that you see that atoms are this atoms comes to form molecules form organelle in a cell, and organelles form organisms in a cell. Then the cells aggregate to form tissues form organs system, and organ system forms an organism. Now, organisms that are of the same species will form a population, while populations of organisms will form a community, while the community of organisms, whether plant or animals, will form an ecosystem. While an ecosystem will form a biome. The biome is more of a terrestrial habitat majorly, while that biomes will form a biosphere. In a minute you're going to see the definition of, yes, these are the different things to get yourself familiarized with. But before we do that, what's the definition for ecology itself? Ecology is defined as the relationship or interaction between organisms within themselves and their environment. I take that again. Ecology is the relationship or interaction between organisms between themselves and their environment or their habitat. So it means that if I have if I want to define ecology using goats and wet feeding, that means I would say ecology is the relationship of goats within themselves and other living organisms, which could be other goats, man, rats, ants, or grasses that they feed on, or say the sun shining over their heads. All right, so look at this. So the things that the terms you need to get used to in ecology are the following. So habitats, that's a place where an organism lives, and these habitats could be divided into three: aquatic, terrestrial, arboreal. Even though some books believe that arboreal is a subset of terrestrial, then aquatic refers to living in water where we have fresh water, marine, and estuarine. Basically, fresh water doesn't have salt, marine is salty water, while estuarine is a mixture of the two, so to say. All right, so it's that's for aquatic habitat. while terrestrial refers to all living things living on land, basically. But arboreal is referring to living things living on trees and say in the sky. So why some books disagree with the fact that arboreal should stand on its own is because arboreal, even the trees are found on the terrestrial habitat, all right, and it's not so. Some literature has it that it's not valid that any living thing can stay in the sky all its life. So basically, just take it the way I've said it. Majorly, you have aquatic and terrestrial. If it's not wrong totally, I wouldn't want to go into the argument now to agree to the fact that there's also arboreal, terrestrial, arboreal habitat, I mean to say. All right. So moving on, we now have a population. A population is a group of organisms belong to the same species. Your key word here is the same species. Why? Because when we say, even in Nigeria, when population census is being carried out, it is carried out on humans which belong to the same species, not population of they will not count goats with animals. All right. So it is, if you want to do population of goats, then that's population of goats because it has to be the same species. All right, bear that in mind. While community refers to all population of different organisms living and interacting in the same space at the same time. So if I look at a field, a grazing field, let's assume you have rats on that field. Let's assume you have goats on that field. Let's assume you have rams and cow on that field, cattle. So if that is the case, that will mean that the population of goats plus the population of cattle, I beg your pardon, the population of rams, population of rats, population of other, say, earthworm inside the soil, that will form a community. Population of the grass they are feeding on. All right. So population comes together to form a community. But a community will come together with the environment to form what? An ecosystem. Now you can say a community of living organisms and the abiotic. So now we are now adding the non-living things. Say the sun, the wind, the water, the soil. All right. So look at what I just explained. Then add all the non-living things that could be in the environment plus the community. That forms the ecosystem. So what are abiotic factors? These are the physical and chemical features of the environment. What are biotic factors? The features. So having established that biotic factor refers to the living things, then we go to niche. Niche, sometimes people tend to confuse it for trophic level. It shouldn't be confused. Niche in this regard refers to the role of a species in its habitat. The role, not the position. The position is trophic level. All right. So they almost have the same. Some people say the role something occupies, and they don't give it. So the role that an organism plays, that is niche, while the level or position it occupies as the trophic level. We'll get to see that later on in the lecture here. All right. Okay, now like I said earlier on, let's just look at the diagram to explain what I said. Now this is a community. Yes. Now this is an organism. This is an organism. So if you have plenty crocodiles, that will be population of crocodiles. So when you have population of crocodile plus population of flamingo, population of dog, population of fish, population of snakes, population of aphid, population of earthworm and grass, that becomes what? A community. Now the moment you now add the non-living things around here, say the air they breathe in, say the sun, though that's not shown here, say the soil from which these grasses grew, that becomes your ecosystem. Alright, so bear that in mind. So all of these living things are the biotic factors. All these living things, including the grass, because it's living, are the biotic factor, where the sky, the water in the soil, the sand, some other things that are not living, the water, the wind, that will be the what? A biotic factor. Alright. Now, when we say, you see, each species occupies different niche, that means different role, not just position, please, role. Now, though this is not totally clear all the way, but this is a tree. Some of the tree, the birds are found at the tip, at the middle, at the bottom. Some are found on the stem. Now, so the role it plays, say for example, this is feeding on seed. Let's say this is feeding on ants. Let's say we have a woodpecker that feeds on ants within the stem. So that is the role it plays, and that is habitat. Let's imagine on the same tree we have some organisms living within the roots, the earthworm around here. That is its niche, found at the habitat. That would be, so in this case, that means if you want to compare earthworm here, the earthworm on this tree will be found in the root. That would be what? Terrestrial, inside the soil. While these ones might be arboreal because they are found on the branches. Alright, so you can see each. Okay, let me see. Okay, the role this species plays, and it includes the type of food it feeds on. Beautiful. Like I said, if this one is feeding on seed, so it's feeding on ants. So this is an herbivore, this is a carnivore. Alright, where it lives, is it on the tree or in the soil? Where it reproduces and its relationship with other species. Alright, I think that is easy enough to understand. Now, earlier on we said that, let's quickly go back to one of those slides. Here, this slide says we have biosphere as the, like the biggest of all the categories or hierarchy. Now, the biosphere is divided into three majorly, and those are your atmosphere, your lithosphere, and your hydrosphere. The atmosphere refers to the gases, the sky above us. Lithosphere refers to the sandy aspects majorly. Now, please say this: soil and minerals, land for humans to use, water under the ground. So because you know that when we dig our wells and boreholes, basically they come from the soil. So everything within the soil is lithosphere. While the hydrosphere refers to the water bodies, right? All the water bodies, the oceans and the likes. Alright. Now moving on. In an environment, or in a habitat, or in an ecosystem, there are instances whereby population needs to be counted or needs to be known. And for the sake of any of the exams we're writing, it's important for you to know, familiarize yourself with some of these things. Like I said, I will not go into in depth to this. So since we know that population are organisms of the same species, alright. Then, okay, to calculate the population size, we have the density times the area of habitat. Now, what are the factors that affect population? Those will be migration. That means when organisms migrate out, migrate to a place. So that means if we have part A and part B, or habitat A and habitat B, then the organisms at or in habitat A moves to habitat B. Apparently, the organisms at habitat A will reduce, and those at habitat B will increase. And the factors, I mean the things available at these places will be affected. Probably the ones at habitat B will be overpopulated, depending on how that place was initially. So basically, these are the things that affect population when organisms populations move from one part to the other. Then we say invasion, when some organisms invade or enters a place. Say for example, if some carnivore just invades a habitat where we have lots of herbivore, so there's tendency that the herbivore will be fed on or will be killed by the carnivore that just invaded. So that will definitely reduce or affect their population. And we'll talk about increase or decrease in mortality or natality. When we say mortality, death rates. If there's increase in death, apparently there will be decrease in population. If there's decrease in death, there will be increase in population. And if there's increase in natality, that's giving birth, definitely there will be increase in population and vice versa. Now, in conducting a population study, the following are used depending on what population the population you are trying to study. Is it big animals, is it small animals, are they insects, are they flying insects, are they swimming insects? It depends. Alright, so, and the aim is to catch them, and when the animals are caught, we estimate, you can see density and area of habitat. So when the amount you catch at a time, then you multiply it around by the habitat, the area of the habitat, because it's not easy. You can't literally count every organism there. Alright, so you just approximate. But to approximate, you need these things here to catch the samples. There's something called population sample or sample size. Alright, so now the putter, the sweep net, and the quadrat or the transect. Now when we say quadrat method and transect method, they are both things used to count. It's not as if you will get to see that in a few moments. So this is a putter. A putter is used to collect insects. This place right here is put into, let's say you want to collect insects from the bark of a tree. Some bark of a tree have holes that insects, say mosquitoes and the flies, bees are in them. So when you want to collect those, you insert this end into the back of the tree, and the mouth is put here to suck in. So once you suck that in, this is fine cloth. So once you suck that in, the insect goes into this place. Alright, so the insect are prevented from entering one's mouth by this net, or let me say this perforated cloth. Alright, yet this cloth can allow air to move in. So you just gather the insect here, this place is covered. Once it is withdrawn to prevent them from escaping. Alright, then this is a sweep net. A sweep net is used to hold insects, just sweep it in the air, then some of the insects that are caught will be counted. Alright, then we have quadrat. This one is majorly used for counting small population. I mean, you can see here now, this is counted. So what happens, each of the quadrat here, the populations, so there will be this what will be done. There will be a table here on this man's book for grass, maybe for earthworm, for grasshopper, for this and that, different population. So for each quadrat, you will count the number of grasses in this quadrat, like that, for those different population. You know what I'm saying? Because you have population of grass, of earthworm, of insect, different depending on what you have here. All right, so it's what he sees here that will determine the kind of table he's going to draw. All right, so when we now say transect method, we're also counting, but this time around in a bigger way. You can see here, this is a line, so all the organisms within this line are counted. Then that we used to estimate for this whole area. All right, so like you count, you can see them counting. Moving on. Now, when we say abiotic factors, what are abiotic factors that are common to all habitats, say terrestrial and aquatic, or even arboreal? And these are temperature, rainfall, light, wind, hydrogen concentration, and pressure. Now, I will mention two major things. One of the most important abiotic factors that determines any habitat, any habitat, but either terrestrial or aquatic, are these two: temperature and rainfall. Now, let me add this at this point, that these two determines the vegetation. Temperature and rainfall determines vegetation. Vegetation determines the kind of animals you have in a place. This is very important. If rain falls in a place very heavily, apparently you have more plants. The more plants will determine the kind of animals it attracts. Alright, so that is the trend. Temperature and rainfall determines vegetation. Vegetation determines the type of animals. Factors affecting aquatic habitat alone: salinity for the marine, density, turbidity. All of these are things you are familiar with if you see my video on habitats, on aquatic, terrestrial, and arboreal. If you see my video on that, you understand what this means. But let me explain turbidity. Turbidity talks about how clear a water body is, how transparent it is, how easy for you to see through the water. Can you see the depth of the water while standing at the bay or at the back of the river? So that's what turbidity is. Moving on. So what are the factors that are peculiar to terrestrial habitat alone? You can see relative humidity, but let me still explain some few things here. Relative humidity refers to the say the amount of moisture in the atmosphere. That's what relative humidity means. Amount of moisture in the atmosphere. Then you can say land surface. Is it slopey? Is it hilly? Is it soft? Does it have contour and the likes? Alright. Moving on. Then we have here that there are some equipment used in measuring abiotic factors, and like I told you at the beginning of the video, as it is, that you should once in a while pause the video to write things that if you need to, probably what is on the screen or what you're hearing from me. Now, all of these, there are actually more, are used for measuring some different abiotic factors. You will see all these equipment in the next slide also. However, I will want you to know that they are not written exactly the way it is here. That's the same sequence. No. So let's get started. So this is what a wind vane looks like. What is it used for? It is used to know the direction of the wind. You can see the 4 cardinal points here: north, south, east, and west. So at the moment from this diagram, it shows that the wind is blowing towards the west direction. Alright. The next diagram here is referring to an anemometer that talks about the speed of the wind. So this will be blowing around like that. So there's a counter here that talks about the speed of the wind. So it tells us, okay, how fast the wind is blowing. Then we have your rain gauge. The rain gauge is used to measure the amount of rainfall per annum. Alright, so you can see here the measuring cylinder. So that it's not all the time per annum. It can be used depending on what, but it's used to measure the amount of rainfall. Alright, that's what we call it, rain gauge. So this is the collector here, the measuring cylinder here. Now moving on, this is just the part of the rain gauge. You can pause the video to do that. So we have your wet and dry bulb hygrometer. Hygrometer is spelled HYGROMETER. It's amongst those I mentioned. What's it used for? For measuring relative humidity. What's relative humidity, if you can remember, is the amount of moisture in the atmosphere. How wet or how dry is the atmosphere? Alright, so this is what is used to measure it, a hygrometer. Then we have our Secchi discs. You can see Secchi discs. The aim is to measure what? Turbidity. What's turbidity? How clear or how dirty. Can you see? It's used to compare how clear, how dirty, or how well you can see through a water body. You can see here. It's easy for you to see the Secchi disc here. But this one, probably if it's dropped down, you won't be able to see the Secchi disc anymore. That means this water is turbid than this one. Alright. Then we move on to biome. Biome is a community of plants and animals that have common characteristics for the environment to exist. So they all work together. Alright. So the only thing is that because you might want to say biome and ecosystem is almost the same thing. Yes, you might want to think that, but biome is a large ecosystem, a very large one. You must always have that at the back of your mind that okay, it's a large ecosystem, or you can say a large terrestrial ecosystem. All right. Okay. Most time it deals with terrestrial. Yeah. So I think this will be your distinguishing word. A biome is a very large ecosystem that is majorly what? Terrestrial. All right. Now, the biome can be, we have two categories majorly: world biome and local biome. Sorry, this is meant to be local biome, not biome local. All right. Now, the local biome here in this case is Nigeria, which is our domain. That's what we're going to use. So we have these four major biomes: the mangrove, the tropical rainforest, the savanna, which is divided into Guinea savanna, Sudan savanna, and Sahel savanna, and desert. Bear in mind that as we move from the mangrove down to desert, the temperature increases while the rainfall reduces. I take that again. From here, mangrove, down to desert, the temperature rises while the rainfall reduces. So the higher the rainfall, the lesser the temperature. And if you move from the desert to mangrove, that means there will be increase in rainfall, decrease in temperature. So like I told you earlier on, that temperature and rainfall determines what? Vegetation. So if you have more rainfall around here, that means you have more plants around here, least plants around here. Because temperature is so low here, there's increased temperature here. Temperature is so high here, rainfall is so low, and that doesn't favor growth of plants. Apparently, number of animals. Alright, so let's look at. So let me quickly mention it. I will try to slow down so that you can put that down. So I'm calling out the names of the states in Nigeria that fall within this category. So for mangrove, you have let's say, okay, majorly they are the coastal regions of Nigeria, such as Cross River states, rivers, delta states, and let's say the delta part of Lagos State. All right. The other part means the part that are closer to the ocean majorly. Then for tropical rainforest, where you have trees, don't worry, in a minute I will show you diagrams of all of these. We have the likes of the southwest region, which is your say Ogun State, Ondo State. Funny enough, we also have some states from mangrove that also falls here, that have a part of them being mangrove, a part of them being tropical rainforest. So those parts that fall within the two of that, they are also that are also the tropical rainforest are your river state again. That should be, I'm going to recall, that should be the Cross River again. Yes, if you remember, that is also here and that is also here. All right. Then what I want to say about mangrove before I forget is that mangrove swamp have some plants called mangrove, and we call them white mangrove and red mangrove. The white mangrove have one particular characteristics, which is they have a breathing root. I will show you that in a minute. Breathing roots that helps them to take in oxygen and the carbon dioxide that gaseous exchange. They do that. Those breathing roots are called nematophore. That is PNEUTOPHORES. All right. That's that. Then moving on, when we talk about Guinea savanna as the first one, savanna majorly has to do with field. All right. So the Guinea savanna, we have the states from Guinea savanna in Nigeria are found in parts of Kaduna, Kwara State, and Benue State. While Sudan savanna, example of those are, let's say, Kano and parts of Borno and Sokoto, Niger, Gongola, and Bauchi states. But Sahel savanna is going towards the extreme part of Nigeria, say Lake Chad. Just you are already going out of Nigeria. That's very, very dry. Then we move on to desert. We don't really have desert in Nigeria, really, sincerely. Now let's now show you the diagram of what each of these things looks like. This is the mangrove swamp. All right, these are the breathing roots. You can see it here. It's not really zoomed out for you to see that. Zoom in for you to see that, but majorly just this is what the mangrove swamp looks like. You can see water around here. This is swampy area. Even when you look at this side here, if you walk around here, it's going to be very, very meshy and sinky. All right. Then moving on, this is our tropical rainforest. You can see evergreen vegetation, because rain is much around there. Like I told you, the more the rain, the more the vegetation, and the kind of animal you attract. That means you're expected to have tree climbers here, snakes, and the likes. All right. So pay attention to this. Then now we now have our Guinea savanna. You can see it's becoming drier now. We still have some trees. We have more grasses compared to rainforest where you have majorly trees. All right. Then we have the Sudan savanna. You see, it is drier compared to Guinea savanna. Like I told you, as you move from mangrove towards desert, it becomes drier because there are lesser rainfall and higher temperature. Then we have our Sahel savanna. This is really, really, really dry. This is like almost half of Nigeria. We don't really have all this in Nigeria all the way. That's what we say towards Lake Chad. That's the boundary of Nigeria. Then we now have the desert. All right, this is totally out of plants hardly grow here. There are only few plants that can grow around here. All right. So let's move to ecosystem a little bit. We say that's the basic function unit of the nature. All right, and it's made up of organisms with organisms. That's communities of organisms living with their abiotic environment. So this is biotic and abiotic. All right. So the biotic components are grouped into autotrophs, which are organisms that have ability to make their own food, from their own food, and that will refer to the producers, the consumers, and the decomposers. That's your autotrophs. So I mean, okay, now sorry, I beg your pardon. Let me say that again. When we say producers, that would be the autotrophs. The consumers will be the heterotrophs. All right. Then the decomposers will also be under the heterotrophs. So, but basically speaking, all biotic factors are either what producers, which are autotrophs, or consumers, which are what heterotrophs. Now, there's something called a food chain, and a food chain refers to what? A linear feeding pattern. All right, that's a linear feeding pattern. So you will see that it's a straight thing. All right, living things feeding on the other one. Now the arrow is always pointing to what is eating it. Let me give you a simpler diagram from here. This should be easier. Okay, yes, this is a linear feeding pattern in organisms. So it means grass is eaten by grasshopper. Grasshopper is eaten by what? Frog, and frog is eaten by python. Now, in any food chain, any food chain, the first organism is always a producer, whether terrestrial or aquatic. All right. Now, the first organism to feed on the producer is called primary consumer. The one to feed on that is what? Secondary consumer. The one to feed on that is what? Tertiary consumer. And then you can have on and on and on. All right. So this is another diagram showing you food chain. It's a linear. You can see. Though this really does not really exist alone, because organisms don't feed on just one type of organisms. They just feed on one kind of food. They have multiple choice, and that brings us into food web, a complex feeding pattern which gives organisms options on what to feed on. They have more than one options. They have things to feed on. Say for example here, a lion can feed on wild cats, can feed on jackal, can feed on goat. Alright, you can see the owl can feed on mouse, can feed on okay, sorry, it can only feed on one thing here. I'm trying to look for an organism that has multiple yes, you can see this can feed on mouse, can also feed on rabbits. Alright, so the aim here is just for you to see that this already exists in reality. That because living things don't have one option, one thing to feed on. If that were to be the case, that means once that is not available, say for example, lion can only feed on wild cat. That means once wild cat is not available, it's going to die. That's going to be extinction to its species. All right. Now let's talk about tropic level. Yes, I said this is the position. I was comparing the other time, the position an organism occupies in the food chain. Is it at the first one? Is the second one? Is it the third one? So you can see that here. So these are tropic level. Tropic level 1, 2, 3, 4, 5. So 4. I'm going to use this to explain a number of things. Now, there's something called energy flow. Energy flow is okay as energy flows from the producer to the primary consumer, secondary consumer, tertiary consumer. Now, in this case here, the funny thing about energy is that for every tropic level, the energy that is given to the next level is just 10% of the initial level. What does that mean? We had 100% here. So to this level, what is given is just 10%. To this level is 10%. To this level 10%. Now you ask, where is it 90% that has been given into what? Into the atmosphere, given off as heat. All right, so 10% to this 10% to this 10% to this 10% to this. So the energy is greatest at the what? First tropic level here, at the closer level. Sometimes we tend to think of, okay, since this is let's say this is you can see here, I'm trying to check, okay, we have E good here, we believe that the energy should be more. No, the energy is highest at the source, which are the producers. So now we now have what we call ecological pyramid, and this is a pyramid which is sincerely can be used to explain even the three of these. All right, so this is a pyramid, and this is a rect pyramid because the pointy head is up and the bottom is down here. You can say that. Now if I want to use this to explain pyramid of energy, you can say that the energy is reducing like that. If I want to use this to explain pyramid of number, the number is reducing as we move from here to here. That means we have less millions of grasses. What fits on them will definitely be lesser than them. So let's say we have here 1,000 grasses. Here we have primary consumer, that's mouse and rabbits, let's say 100. Let's say what fits on them, let's say lion and whatever it is. I'm actually using what is here. I'm just saying my own example from the head. Let's say we have cats and let's say we have 50. Let's say lion that fits on those, let's say 10. So you can see it's reducing. Then we say biomass. Biomass means the weight of an organism, which is going to be the summation of its dry mass and wet mass. It is believed that the wet mass of an organism is not the real mass, but the dry mass. All right, so let's move on. You can pause the video here to see, like I told you, this at the level, tropic level, these are the different level, the position. Now let me explain this now. Detritivores and decomposers. Detritivores are organisms that feed on decayed matter. There are two different things here. Decomposers causes things to decay. What are the organisms that feed on the decayed thing? Those are called detritivores, and that decayed thing is called detritus. Example of a detritivore is what? Your earthworm. They feed on a decayed thing, or let's say leftover rotting things. All right, so you can see that here. So fungi are decomposers, they cause things to decay, and many bacteria. But your earthworm is a detritivore. It feeds on what has already decayed. Vulture can be called a scavenger. It feeds on a dead thing. It doesn't kill it, has already been killed. All right, so you can pause the video to get that, so you can see this again. This upright pyramid of biomass. Can you see that? If you sum up the rats here, all the grasses here, they are heavier than this, than this, than this, than this, because the number, pyramid of number to use. So you can use this pyramid, most time can be used to explain almost everything, both the pyramid of number, biomass, and of energy. All right, we're rounding off. This is an inverted one. Now in this case, the number increases upwards. What do we mean it increases upward? Because the organisms are on top of the trees. So on this same tree we have, these are the herbivores. They feed on the seed. Now on each of them they have their parasites. On each of the parasites you have parasites. So the number is increasing. This is an inverted pyramid of number. I believe you can see that. Now this next one is diamond in shape. You can see it increases. So it was small, increases gradually, then reduces. I'm trying to recall a perfect example of this. I can't really remember now, but this is what this is not common for most O-level examination, say WAEC, JAM, GCE. All right, so this is another one, pyramid of energy. You can see it reducing as you move on, you can see that, you can see that, you can see that. Just you can pause the video to get a better glimpse of that. And that will be all for our class today. I hope you had fun. Keep me posted to know if you're able to get these things, and probably you want me to explain some things more. Thank you. God bless you.